Class. Today we are going to be talking about a new concept, and the new concept that we're going to be studying today is proportional relationships. Now, last week we talked about two concepts that are very important in math. One is the concept of ratio. The second concept that we saw last week is the concept of rate. Now, when we talked about ratio, we talked about two different amounts that are connected, that are related. For example, in one of our previous videos, we saw the number of Mickeys versus the number of um, Batmans. And we got that the ratio was 4 to 7, if I remember correctly. So we had 4 Mickeys for 7 Batmans. And we knew that we could express this ratio in different ways. We can say 4 and then a semicolon and a 7. We also could say 4 to 7. But also we had the way to express it with a fraction. We could say 4 Mickeys to 7 Batmans. And these three ways were ways to express two different quantities that were connected, and we call this a ratio. Now, we also saw last week that we have another concept, which is the concept of rate. Now, a rate is when we have two different concepts connected. And this way, and the way that we saw it was, for example, related to, for example, speed. We talked about that when we are specifying our speed in a car, we would use a rate. We would say that we could go 65 miles in 1 hour. Also, we could have another rate, which is like prices in the store. Like, for example, 3 pounds of apples might cost, let's say, $6.99. So we would express this by saying that $6.99 is the price that we would be paying for 3 pounds of apples. Now, today we are going to introduce a new concept, and this new concept is related to a ratio. The concept is very simple. Expressing a ratio could be done with different numbers, not only with just two pairs of numbers. Let's see an example. If we have 2 6, this is going to be our ratio, 2 6. Can we express this relationship between 2 and 6 with any other number? The answer is yes. For example, if we multiplied both numerator and denominator times 2, we would get a ratio that expresses the same proportion. Let's do that. So if we multiply 2 times 2, we would get 4. And then if we multiply 6 times 2, we would get 12. Now, the question is, do these two ratios, this one and this one, express the same relationship? And, well, let's figure it out. If we simplify these two fractions, would we get the same simplified fraction? Well, let's see. If we divide by 2, 2 divided by 2 is 1, and 6 divided by 2 is 3. Okay? Now let's see if we simplify this other fraction, if we would get the same number. Let's see, I see that we can simplify this fraction divided it by 2, so I could say 4 divided by 2 is 2, and 12 divided by 2 is 6. I can still simplify it a little bit more, divided by 2, because both numbers are odd. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So as you can see, we are getting the same simplified fraction. That means that these two fractions, these two ratios, this one right here and this one right here, they are both proportional. Now, how could we get a proportional ratio from a given ratio? For example, we can just multiply both the numerator and denominator by the same number. Let's have this other example. Let's suppose that we have 1/3. So a way to get a proportional relationship is let's multiply both the numerator and denominator times 3. Times 3. Let's see what fraction we get, what ratio we get. 1 times 3 is 3, and 3 times 3 is 9. I know that these two ratios, they are going to be proportional. Now, if I just change the numbers randomly, for example, if I start 1/3, and I multiplied, for example, this times 3 and this times, for example, 5, 1 times 3 is 3, 3 times 5 is 15, I'm going to know that these two fractions are not proportional because they don't follow the same proportion between the numerator and the denominator, as we have seen on this and on this. So I'm going to have a few exercises for you to practice this concept. Remember that if you want to speed up this video, you can, because it's on YouTube. So you can listen to all this video in a faster pace if you understand this concept quickly. Thank you very much and see you soon. Bye-bye.